Hey, what's up? Welcome to this new video. This one is paper 1-1 of May and June 2012 for A-level math. Now, with that being said, let's move on to question number 1. So here we have to solve the equation sine 2x equal to 2 cos 2x for x between the values of 0 and 180. So one by one, so the first thing that I do realize is that we have sine 2x and cos 2x in the same equation. So what can I do? As we have seen before, when we have sine x and cos x in the same equation, we divide by cos 2x on both sides. Let's see what happens. You will have sine 2x divided by cos 2x, and that will be 2. That will be cos 2x divided by cos 2x. Now, as you can see clearly, this one will cancel out, right? This will go away. Now, sine over cos is what? It is tan 2x will be 2. Now, when tan is positive, we know that we have to look at which quadrants? We have to look at this. ASTC, it will be in the first quadrant and in the third quadrant. This will be the angle directly. Let's call this theta, why not? And this is 180 plus theta, for example, right? Now, here we have 2x is equal to tan inverse of the value of 2. Let's see what happens. So here we have to use degrees, obviously. So degrees, tan inverse of 2, that should be 63.4. So 63.4. And this is the value over here. Now we have to find this one. That will be 180 plus this one. That will be 243.4 degrees. So finally, we're supposed to find the value of x. X will be what? 63.4 divided by 2. That should be 31.7. 243.4 divided by 2. That should be 121.7. Okay, so that will be the answer for the value of x, as you can see, between the value of 0 and 180. Okay. Now let's move on to the next question. So here we want to find the coefficient of x power 6 in this expansion. So pretty easy. We have two methods of doing that. The first one is you can expand everything and choose the one that has a term in x power 6 and provide the coefficient as your answer. Or the second way, you can expand exactly the one that you're looking for. For example, how would you expand this usually? You will take 7, combination something, and here we have 2x power 3, and here we have 1 over x squared. So in this case, we have to choose what power can I choose here so that when I expand the whole thing, I will have x power 6. Now the power can be from 0, 1, 2, until 7 because we have power 7 over here. Again, this is done by trial and error. We don't know exactly at first. We have to see or to try which one is possible. For example, I can think of trying which one. So here I need power of 6. I have until 7 to choose from. So let's think. Which one can I choose? If I choose 2, will that work? That will be too much. If I choose 4, let's try 4. Why not? Let's see what happens. If I choose 4 here, this will be 4 as well. 7 minus 4 is 3. That will be 3. So let's see what happens. So that will be 7 choose 4. That will be 35. Here you will have 8 x power. That will be power 9. And that will be 1 over x power 8. So this is not good. If you were to expand, you will have something in x. So not good enough. Let's try something else. 7 choose something else. That should be 2x power 3. And here we have 1 over x squared. So in this case, I have to choose something way higher for this one. What if you choose, let's see if I choose, if you choose 6, that will be 18. And that will be 1 too much. If you choose 5, if you choose 4, that should be 12. And that should be 6. So perfect. Let's choose 4. That will be 3 here, and that will be 3 here. So that works exactly. If you see 7 choose 3, that will be 35. That will be 16 x power 12 minus 1 over x power 6, right? Now if you were to simplify, this obviously will cancel out. This will be 6. Now we can simplify. That will be 35 times 16. That should be minus 560 x power 6. Now your answer should be just the coefficient, which is the value in front of the power. That should be your answer, minus 560. Again, this is just to make you realize that this is done by trial and error. So for example, I've tried something, it did not work out. I can go to the next term or the previous term to see which one is the term in x power 6. Or the other method is just to expand everything and then choose the one that you need to find your corresponding value. This one will be minus 560 as the coefficient of x power 6. Now let's move on to the next question. So in this diagram, we have ABC is an equilateral triangle of side 2. So first thing we can realize is that since all the sides are equal, it means all the angles are equal. And which means the angle here should be 60 degrees, which is also pi by 3 radians, pi by 3 and pi by 3. All the angles are the same. Now what else? The midpoint of BC is Q. So this is the midpoint of BC. An arc of a circle with center A touches BC at Q. Okay. So if this is the midpoint, it means that this will have to be 1 and this will have to be also 1 because it is exactly the same length. Now what else? So the question is here we have to find the total area of the regions. So pretty easy. So first thing first, we have to find the area of the whole triangle. So how can we find this? There's a few ways to find that, obviously. We can use our formula first to find this. So to find the area of the triangle, that will be half sine of the angle in between, pi over 3, times the two sides, that will be 2 and 2 around the angle. Cancel out, that should be 2. Sine of this is 60 degrees. Now we know sine of 60 is an exact value. That should be root 3 over 2. That should be just root 3. So the area of the whole thing is root 3 units square. Now we need to remove the area of this sector to find the area of that remaining regions. Now we know to find area of sector we have to have half r square and theta, which is the angle, pi over 3. But we don't know the radius. Now what is the radius and how do you find the radius? The radius will be the length AP or AB. But now if you do realize, if you were to join A to Q, it is also the radius, right? AP, AQ, AR, they are all the radius. Now what can we do here is we can kind of form a right angle triangle. So AQC is a right angle triangle. We know this side, we know this side. We want to find the side over here. So again, we have a right angle triangle. We know two sides. We want to find the other side. We use the Pythagoras theorem. That should be what? AQ square plus 1 square is equal to 2 square. So AQ square have to be 3. So AQ have to be root 3. So this will be root 3. So finally, the radius is root 3, so half. Root 3 squared is 3 times pi over 3. That should be pi over 2. Here we go. So the area will be the whole thing, which is root 3, minus pi over 2, which is the area of the sector, and that will be centimeters square for the area of those two regions. Now let's move on to the next question. A watermelon is assumed to be a spherical shape, which means a ball shape, right? Which is growing. Good. Now its mass m and radius r are related by the formula m equal to k r cubed, where k is a constant. Okay, good to know. Now, it is also assumed that the radius is increasing at a constant rate of this. Now rate means with respect to time, so radius, dr by dt, is increasing, so positive value of 0.1 centimeters per day. That's the rate of increase of the radius. Now, On a day, the radius is 10. So when the radius is 10, so right now, at the time of this question, the radius is 10. And the mass is 3.2 kg. Okay, we have to find the value of k and the rate at which the mass is increasing on this day. So pretty easy. The first thing we can do is find the value of k. So replace back in your main equation. M is 3.2, k is right here, and R is 10 power 3. So k will be 3.2 divided by 1000. That should be 3.2 times 10 power minus 3. Okay, that will be your value of k. Now let's move on. So what else do we need to do? We have to find the rate at which the mass is increasing. So we have to find dm by dt. So we have to form an equation by using the chain rule. On top we have dm, so we write dm. On the base we have dt, so we write dt. Now they are related by something, which is obviously dr will be the only other option. So here we know this is what value? dr by dt is 0.1 given to you. Now we just have to find dm by dr. Now good news, we know m is already given to you by k r cube. So dm by dr should be 3kr squared. So replace when the value of r is 10, right? You will have 300 times k, which is 3.2 times 10 power minus 3 times 300. That should be 0.96. So finally replace back in your main equation. That will be 0.96 times 0.1. That should be what? 0.096. And that will be the rate of change of the mass, which is kg, in a day. Okay, and that will be your answer for this question to finding the rate of increase of the mass and the value of k. Now let's move on to the next question. The diagram shows the curve y equal to 7 root x. Again, I can rewrite this equation. That will be what? 7x power half, right? Now what else? Now we have a straight line y equal to 6x plus k, where k is a constant. As you can see here, this is my straight line. Good. The curve and the line intersect at the point A and the point B. So we have 2 points of intersection. Now for the first part, for the value of k, for the case where k equal to 2, if k is 2, the line will be 6x plus 2, right? Now we have to find the x value of the point A and B. So pretty easy. We have to find the points of intersection. So let's replace. So here we have y as subject, here we have y as subject. We just have to solve simultaneously, right? Because the points A and B are the points of intersection. So on one side you will have 6x plus 2 is equal to 7x power half. Send everything to one side, you will have what? 6x minus 7x power half plus 2 have to be 0. Now right now we do have a quadratic equations. So if you're not too sure, we can do something. Let's try to let u is equal to x power half. That should be 6u squared, because we understand that x is x power half square, right? Because of that, that can be u squared. Minus 7u plus 2 is 0. Now we have to try to solve this and then try to find the value of u. So in this case, let's see what happened. So factorize. 6 is 3u times 2u. And here we can have 2 times 1. We need minus 7. We can have minus 3, minus 4. That should be minus 7. So u will be 2 over 3. U will be the value of half. So now we're not trying to find the value of u. We are trying to find the value of x. Replace back. X power half is 2 over 3. X power half is 1 over 2. Square both sides, you will have x here, and that should be 4 over 9. and here you will have 1 over 4. Here you go. The x value of a should be 1 over 4. Let's see which one is bigger. 1 over 4 is this value. Sorry, 0.25. 4 divided by 9 should be 0.444. So obviously this happens before this one. So obviously a happens before b. So the first point here should be 1 over 4. And this should be 4 over 9. Okay, so the x value of b will be 4 over 9. Now let's move on to part 2. Now find the value of k for which this is a tangent to the curve. So it means that it touches the curve at only one point, and because of that we understand b squared minus 4ac have to be equal to 0. So let's solve. So you will have this equation for now, right? By solving simultaneously, you will have 6x minus 7x power half and plus k instead of 2 equal to 0. Now obviously we know this is a quadratic equation. For example, that was what? That was the value of, this is a, b, and c. So b squared is 49 minus 4 times a times c have to be 0. So 4 times 6 will be 24 here. K has to be 49. So k has to be 49 divided by 24. That should be 1 over 24. That is my value of k. And that will be your question, part 2, into finding the value of k, only one value, when we have b squared minus 4ac equal to 0. So here we have two vectors u and v are such that u is defined by this and u is given to you by this. So we have two vectors, okay, given to you. Now, part 1, we have to find the values of p for which u is perpendicular to v. So when a vector is perpendicular to the other one, we have to understand their dot product have to give you 0. So that's the main thing behind this question, part 1. So if you perform dot product, we have p squared minus 2, 6, dot of 2p minus 1, 2p plus 1 have to be 0. Now we can just multiply. You will have 2p squared, that will be minus 2p plus 2 plus 12p plus 6 have to be 0. Simplify, you will have 2p squared plus 10p plus 8 is 0. Now because all the numbers are even, we can divide by 2. You will have p squared plus 5p plus 4 is 0. Now we have a quadratic equation. We can factorize to see what happens. P is p times p, 4 is 4 times 1. To get plus 5, we have to have plus 4 plus 1. So p can be minus 1 or p can be the value of minus 4. So this is part 1 for the values of p, two values, minus 1 and 4. Now for part 2, for the case where p is 1, now we know p is 1, so which means u will have to be 1 minus 2, 6, and v will have to be 2, 0, and 3. We have to find the angle between the directions of u and v, so pretty easy. To find the angle, we have to use dot product equal to magnitude of the two vectors times cos of the angle in between. Let's call this angle angle O, angle A, why not, whatever. So u is 1 minus 2, 6, v is 2, 0, 3, and the magnitude will be what? So pretty easy. 1 square plus 2 square plus 6 square. That should be root of 41. This will be 4 plus 0 plus 9. That should be 13. Now because of the angle in between, let's see what happens. So here we have to perform dot product. So 1 times 2 plus minus 2 times 0 plus 6 times 3. That should be 20. Then divide by these values. So root of 41, root of 13 have to be cos of the angle in between. Now 20 divided by root of 41 times root of 13, that should be this. So cos inverse, that should be what? The angle in between should be 29.968 degrees. Correct to one decimal place, that should be 33.0 degrees. And that will be your answer for part 2 of your question. Let's move on to the next question. The first two terms of an AP are 1 and cos square respectively. So we have an AP here. The first term is 1 and the second term is cos square x. Now we do know that for AP we have a common difference. So here to here we have to plus something, plus d. So 1 plus d have to be cos square x, which means d have to be cos square x minus 1. Great. Now what else? So we have to show the sum of the first 10 terms can be expressed in this form. So let's try this. What is the sum of the first 10 terms? It is half times n, which is 10, times 2a. 2a, a is the first term, plus n minus 1. N minus 1 is 9 times d. d is cos square x minus 1. Now we just have to simplify and express this in this form. So step by step. So at first we can simplify this. 2 goes away. Here we have 5. So 5. Here we have 2. And here we have plus 9 cos square x minus 9. That will be 5. 2 minus 9 should be minus 7. Plus 9 cos square x. Right. Now we can try to expand. Why not? That will be minus 35 plus 45 cos square x. That should be minus 35 plus 45. Now what is cos square x? It can be 1 minus sine square x, right? So that will be minus 35 plus 45 and minus 45 sine square x. So the last step is to simplify this one. That should be 10 minus 45 sine square x. So it needs to be in this form. As you can see, it is exactly in this form. That will be part 1 of your question. Now for part 2, the first two terms of a GP now are 1 and this one. So we have the first term and the second term. So first term is 1, second term is 1/3 tan square theta. Now we understand from the first term to go to the second term we have to multiply by r because we know it is a GP, right? That should be what? So we know 1 times r have to be 1/3 tan square theta, which means r is actually 1/3 tan square theta. Good to know. Now what else? Now we have to know the value of theta is between 0 and half pi, which means it is in the first quadrant. 0 and pi over 2 will be here, first quadrant where everything is positive. Now part 1, we have to find the set of values of theta for which the progression is convergent. So we have a GP. A GP is convergent when r is less than 0. So when we have this, right? Less than 1, sorry, not 0. So let's write this. So here we have r as what? R is 1/3 tan square theta less than this. Now if you were to kind of rewrite this as what? We can simplify this. That should be 1/3 tan square theta have to be between minus 1 and this. Now obviously it cannot be negative because square of a value cannot be negative. Right, makes sense. So what is the closest number, non-negative number that we have next to minus 1? Should be 0. Because you have minus 1, 0, 1. So what is the closest number which is non-negative? Should be 0, right? There'll be this, 1/3 tan square this. Now simplify, we have what? Multiply by 3 everywhere, you will have 0 here. This will go away, you have tan square less than 1. Now tan theta will be 1 as well because square root of 1 is 1. Again, we will not be taking the values of negative here because you can see it is in the first quadrant where everything is positive. Now to find the value of theta, we have to take tan inverse on both sides. That should be 0 here, and this will be the angle of Okay, so here I'm missing something. Should be 3 here. My apologies. 3 and 3 here. So here that should be root 3. Sorry, root 3. Because when I multiply by 3, this should become 3 and not 1. That is my mistake. So that will be this, and this should be tan inverse of root 3. And that should be what? Let's check. Tan inverse of root 3, that should be 60 degrees, which is pi by 3. So, set of values of theta will be this one. Again, the main thing is our GP is convergent when we have this. So that's the main thing we have to know. And then from this, we can proceed step by step and solve for the values of theta. Okay, so let's move on to part 2. So we have to find the exact value of the sum to infinity when theta is this. Okay, so let's see. So when theta is equal to pi over 6, which is what? 30 degrees. We have the first term is what? The first term is 1, and r is 1/3 tan 30 square. So tan of 30 degrees is this, square will be this. Now what is this value? 1 divided by root 3? Nope. Let's check. Because we don't know something, we can try. If you don't remember, we can always use a trick, right, to find this value, exact value. Because usually we have what? Let me just show you guys. Usually we know sine of 30 is equal to half. Now we use the right angle method. This is 30. Half is what? Sine is what? Sine is opposite side, which is opposite here, 1. And this is the hypotenuse. Now we have to find this side. This will be found by using the Pythagoras theorem. That should be 4 minus 1 root. That should be root 3. Now to find tan is obviously 1 over root 3, which is the O side over the A side. So now we have tan of 30 is 1 over root 3. Now square of that should be 1 over 3. Right? So here we have 1 over 3 multiplied by 1 over 3. That should be 1 over 9. So at the value of theta is equal to 30, we can derive the value of r is 1 over 9. So finally, the sum to infinity will be a is 1 over 1 minus 1 over 9. That should be 1 over the value of 8 over 9, which is 9 over 8. That will be your sum to infinity. And that is part 2 of your question. So now let's move on to the next question. Here we have a function f of x is equal to this. Okay, x squared minus 4x plus k, where it is defined for the domain of x is more than the value of p. Now k and p are constants. Now part 1, we have to express f of x in the form of this, where a and b are constants to be found. So pretty easy. As you can see here, we just have to complete the squares. So step by step, at first we have what? We have 1 x squared minus 4x plus k. Now since we have 1 here, we can proceed to the next step. So that will be x squared minus 4x. Now we have to add something. The number will be this one, which is 4 divided by 2 square. And then when you add something, you also have to minus the same value, which is 4 over 2 square. The reason is because you don't want to change your equation. So when you add something, you minus the same value, so your whole equation at the beginning will be the same. It doesn't change. Now we have to simplify. The value here on the inside will become what? So here we have x squared, but here we have x, that will be x. Here we have minus, that will be minus. 4 divided by 2 is 2, that will be 2. Here we have square, that will be square. Now here we have plus k minus, that will be divided by 2, square will be 4. Okay, so now we can rearrange in the same way as this. That will be x minus 2 square plus b plus k. Okay, this is shown as required for part 1 of your question. Now for part 2, we have to state the range of f in terms of k. So pretty easy. The range of f is the y values of the function, which is the up and down values. So let's have a look. The main idea behind this is we can always use the graph or understanding of the graph to find the range. For example here, What is the shape of this graph? You can see it will be a minimum curve because the coefficient of x squared is 1, it is positive. The shape will be something like this, right? Now, since we know the value at the end, right, is always the minimum or the maximum value, but in this case, since we have a minimum curve, it will be the minimum value. So the value here will be the value at the end, which is k minus 4. Now, so obviously the range will be what? So by observation, you can see the range will be, which is the up and down value, it will be always more or equal to this value. So pretty simple. So f, the way you write range, you write f, or you can write y, but we can write f has to be more or equal to k minus 4. As you can see on the graph, you can see exactly what's happening as well. We have a base value and then it keeps going up, right? So this is the range of f. Now for part 3, we have to state the smallest value of p for which f is a one-to-one function. Okay? Now, for it to be a one-to-one function, we have to understand that, for example, if I were to draw a line here, a horizontal line, you can see we have 2 points of intersection. So it is not a one-to-one function, right? Now, to make this become a one-to-one function, we have to kind of define the graph for this. So from the minimum point and going on, we have to forget this side. Only then, when you draw a line, you have only 1 point of intersection, and hence it is called a one-to-one function. Now, we have to find the value of p. Where is p? P is right here, this one, right? As you can see, x have to be, x is the horizontal values, right? So x have to be more than this value, so this value is p, so that we can have a one-to-one function. Okay, so what is this point? As you can see, this is your minimum point, the x value of your minimum point. So how do you find this? We can use this to, or this to find that. So we can say at the minimum point, we can just take the value inside, which is x plus a, which is x minus 2, equate that to 0. So x will be equal to 2. So at this point, here we have 2. Now, as you can see, when x is more or equal to 2, our function will be a one-to-one function. Because when you draw a horizontal line, we have only 1 point of intersection. So by understanding the drawing, by understanding what's happening, we can understand that the smallest value of p can be the value of 2, so that we can have a one-to-one function, right? Now for part 4, for that value of p, we have found in part 3, we have to find an expression for f inverse of x and state the domain of f inverse, giving you answer in terms of k. So pretty easy. Now let's move on to finding the f inverse. So first we have to let y equal to f of x. F of x is also equal to x minus 2 square minus this plus k. Now we have to make x become subject. So pretty easy. Y plus 4 minus k will be x minus 2 square. X minus 2, that should be plus minus root of y plus 4 minus k. Now we can have x will be 2 plus minus y plus 4 minus k. Okay. Now, very simple, we have to choose. So f inverse of x obviously have to be 2 plus x plus 4 minus k. Because here we can see x have to be more than 2, so we take the positive value. That will be f inverse of x. Now we have to find the domain. So domain of f inverse of x is the same thing as the range of f. Now we know the range of f has been found to be f has to be more equal to k minus 4. So obviously we use that. But when we express domain, we write x. So you just have to write x has to be more equal to k minus 4. That will be your answer for the domain of f inverse. So something to know is domain of F inverse is the same as range of F, and the range of F inverse is the same as the domain of F. So we can use these values to find these values. So in this kind of question, it is something useful to know that we can use to find the corresponding domain and then get your 4 marks for your answer. So that will be a question regarding the chapter of functions. Now let's move on to the next question. The coordinates of A are -3, 2, okay, and the coordinates of C are 5, 6, okay. Now we have the midpoint of AC is M, so let's find M. So how do you find midpoint? So pretty easy. We take x1 plus x2, so 5 minus 3 is 2, divided by 2 is 1. Then 6 plus 2 is 8, divided by 2 is 4. So this is the midpoint M of AC. Okay, good. And also we have a perpendicular bisector of AC. It cuts the x-axis at B. So we have to understand what is this line. Okay, so simply, if you were to make a drawing, for example, we have our point A here, and we have our point C here, AC. And the midpoint here is M, right? And from M, you will have a perpendicular bisector, which is a line passing through point M at 90 degrees. So this is why it is a perpendicular bisector. Now, we're also given that this bisector, it cuts the x-axis at the point B. So on the x-axis here, we have a point of intersection, point B. So we have to find the equation of MB and then find B. So pretty easy. So to find the equation of a straight line, you must first find its gradient. So let's find the gradient of the perpendicular bisector. But first, we have to find the gradient of AC. Because they are perpendicular to each other, we can derive this gradient from this one. So what is the gradient of AC? That will be y2 minus y1 over x2 minus x1. That should be 4 over 8, and that should be half. So from this, we can have what? The gradient of PB should be -2. So that will be gradient of the perpendicular bisector. Now to find the equation is pretty easy. We need a passing point, which is point M, will be my passing point, 1, 4. And my gradient of PB, which is the bisector, have to be -2. So this is x and y. So y minus 4 over x minus 1 have to be -2. Now we can just cross multiply. You will have what? Y minus 4 have to be -2x plus 2. So y will be -2x plus 6. That will be the equation of the line MB, which is the perpendicular bisector. Now, we have to find the point B. So we know that point B happens on the x-axis, right? On the x-axis, the value of y have to be 0. Replace, you will have 0 here, -2x plus 6. So 2x will be 6, so hence x will have to be 3. So B will be 3, 0. That will be part 1 of your question. Now part 2, we have to show AB is perpendicular to BC. So let's show if that is true. So to show they are perpendicular, we can find the gradient of each of those two lines. So what is the gradient of MB? Sorry, of AB. Gradient of AB. Let's find out. So we have our point A is given to you by -3, 2, and the point B is given to you by, or was found to be, 3, 0. So the gradient will be y2 minus y1, x2 minus x1. That should be -2 over the value of 6. That should be -1 over 3. Now same steps, we have to show the gradient of BC. So B is a point 3, 0, and C is a point 5, 6. So to find the gradient, that should be y2 minus y1, x2 minus x1. That should be 6 over 2, and that should be the value of 3. So you can see, we can multiply them by each other. So gradient of AB multiplied by the gradient of BC, and that will give you -1 over 3 times 3, and that should be -1. This is shown as required. So once you show their product give you -1, we show they are perpendicular to each other. That's how you show for part 2. Now for part 3, given that ABCD is a square, we have to find the coordinates of D and the length of AD. So pretty easy. For example, we can draw something here so we can understand what's happening. So now we are saying that ABCD, so AB, not great, but you get the idea, right? Not perfect. So here we have what? A, B, C, D. For example, it's a square, so all sides have to be the same, right? Now, what we have to find the point of D. So the idea here is that we, to find the point of D, we can use vector move, because as we can see, from C going to, so from B going to C, have to be the same from A going to D, because it is of the same length, right? So B going to C, so BC will be what? Direction of BC, that will be OC. OC was found to be 5, 6 minus OB. OB was 3, 0. That was 2 and 6. So we use a vector move of 2, 6. So 2, 6, I guess, in the real direction to go from point B to point C. Now, same thing, to go from point A to point D, we have to use the same move. So A going to D have to be the same move, right? Again, the diagram here is not accurate. It is only an illustration to understand the kind of move I'm trying to explain. It may not be in the same direction, but it could be up, right? But I guess the main idea behind this is to understand what kind of process or what kind of trick we can use here to find that vector. That should be OD minus OA should be this, so OD will be this plus OA. OA is minus 3, 2. That should be minus 1, 8. So the point D will be minus 1, 8. Okay, that will be part 3 to find the coordinates of D. So finally, we have to find the length of AD. So A is the point minus 3, 2, and the point D is minus 1, 8. So you can find this by using our formula we know, right? And that will be square root of, that will be 4 plus 36, 40. That should be square root of 40, that should be 6.32 units. That should be the length of AD. Okay, so that will be your question part 3 for coordinates geometry. Okay, so let's move on to the next question. It is given that the curve has equation y equal to f of x, where f of x equal to x cubed minus 2x squared plus x. Now, part 1, we have to find the set of values of x for which the gradient of the curve is less than 5. So the gradient of the curve is what? We have to know it is dy by dx. Have to be less than 5. So let's find dy by dx. So dy by dx will be 3x squared minus 4x plus 1 less than 5. Send everything to one side, you will have this minus 4x. 1 minus 5 is minus 4. Now obviously we have to find the critical values of x. So first let's factorize. That should be 3x times x. This is 2 times 2. To get minus 4, we have to have minus 6 plus 2. X will be minus 2 over 3. X will be the value of 2. Again, these are the critical values of x, not your answer. So we have to use the graph here. That will be 0. Because here we have 3, which is a positive value, the shape will be something like this. Right. Now here we have the first value, and here we have the other value. This is 2, and that should be minus 2 over 3. Now, by observation, you can see we need these values to be less than 0, less. So below should be the values right here. So obviously, x have to be between the value of 2 and minus 2 over 3 for that to be possible. That will be part 1 of your question. Now, we have to find the values of f of x at the 2 stationary points on the curve and find the nature of each point. So pretty easy. So at the stationary points, what do we know? dy by dx have to be 0. So here we have 3x squared minus 4x plus 1 have to be 0. Now we can try to factorize obviously, so that will be 3x times x, 1 is 1 times 1. To get minus 4 we have to have minus 3 minus 1. X will be 1 over 3, x will be 1. So these are the stationary values of the points, two stationary points. Now we have to find the values of f of x, so pretty easy. When x equal to f, so 1 over 3, what is f of x? Let's see. That will be 1 over 3 cube minus 2, 1 over 3 square plus 1 over 3. That should be 4 over 27. Now, when x is equal to 1, what is the value of f of x? That will be 1 minus 2 plus 1 over 3. So here we have 1 minus 2 plus 1 over 3. That should be minus 2 over 3. Okay, so here we have to find the nature of those 2 points. So obviously you can see one of the values here is negative, one is positive, so one is less than the other one. So obviously this one, we can kind of see when x is equal to 1, this will be what point would that be? Nature, as you can see, it is negative here. It will be obviously below, have to be kind of a minimum point. And this one is 1 over 3 should be a maximum point. But again, if you guys want to go through d2y by dx2, that is okay as well. So we have to redifferentiate. That should be 6x minus 4. We just have to replace at dx2 at x equal to 1 over 3. That will be 6 times 1 over 3 minus 4 should be what? Should be that should be 2 here minus 2. If it is negative, it will lead to a maximum value. And when x is equal to 1, it will be 6 times 1 minus 4, that should be 2, and that will lead to a minimum value because it is positive. Again, you have 2 ways of showing that. One is using this, and obviously one you can just conclude by pointing these values out to finding these answers. But again, I think the best way is to show this because they might need this to mark you guys. So always, when you have to find the nature, go by d2y by dx2. Now let's move on to the next question. So here the diagram shows the line y equal to 1. Okay, you can see the straight line over here. Now the part of the curve y equal to this is this. Now what is the first thing we can do? We can rewrite the equation of the curve. For example, I understand that this can be written as 2. That will be x plus 1 power minus half. Right. Now let's move on to the next questions. So part 1, we have to show the equation y can be written in the form of this. So let's try. Why not? So here you can see we have to make x become subject. So let's try that. So let me try this over here. So at first we have y equal to 2 over x plus 1. The first thing we can do is cross multiply. You will have this on top, and we can send the y below. That will be this. Now we can square both sides. You will have x plus 1. That will be 4 over y squared. So x will be 4 over y squared minus 1. So this is shown as required. Part 1. Now for part 2, we have to find the integration of this, hence find the area of the region. So let's see. What can we do? So let's integrate this one. 4 over y squared minus 1 respect to dy. We can rewrite this as what? That will be 4 y power minus 2 minus 1 dy. That will be 4 is 4. Increase the power by 1, that should be minus 1, divided by the power, then minus, that will be y. Of course, plus c. And that will be minus 4 over y minus y plus c. Okay, that will be the answer for this one. Now hence, using that, we have to find the area of the region. Okay, so how did you find the area of the region? So we have to observe here now, because in this case you can see usually we have y as subject when you look at in this direction, but when you have x as subject, we have to kind of flip this over here and have a look of the points that we have on our y-axis. So here we know the point here is 1. What is this point? Let's find out. This is the point when the curve cuts your y-axis. So you know at y-axis, the value of x have to be 0. Replace, let's see what happens. So you will have 0 here, that should be 2. So this is y, not 2, that should be y. 2 on top, you have root of 0 plus 1. That should be 2 over 1, that should be 2. So the point here is 2. So as you can see, we have to find this value over here, and hence we can know the limits of integration. So replace back to find the area. That will be limits of 2, 1, and that will be 4 over this minus 1 dy, which is simply minus 4 over y minus y, and we have limits of 2, 1. That should be minus 4 divided by 2 minus 2 minus 4 minus 1. That should be what? So that should be divided by 2. That should be 2. So minus 2 is what? Minus 2 is minus 4. And here we have minus. That should be minus 5. And that will give you 1 as your answer, which is the area of this one. This is 1 unit square. Now let's move on. Now the area is rotated through 360 about the x-axis, about the y-axis, sorry. Now we have to find the exact value of the volume obtained. So pretty easy. When we have rotation about the y-axis, volume will be pi, and that should be x squared with respect to dy. So when it is y, that will be x squared. So replace. We have the value of x. What is the value of x squared? Square both sides. You will have this minus 1 squared. So let's find out what is that value. So if you expand, that will be 16 over x power 4 minus 8 y power 2 plus 1. Replace back, you will have the volume. Limits will be 2, 1, and that will be 16. This minus 8. That will be this. Now we can step by step solve this equation, or solve this integral. Pi is pi, and that will be what? So here we have first, we have to increase the power by 1, so that will be minus 3, then divide by the same power. Same steps, 8 is only a multiple, we don't care. This will be increased by 1, that should be this, and that should be this, and then here we have 2 plus y. Limits of 2 and 1. Simplify. That should be minus 16 over 3 y cubed plus 8 over y and plus y. That should be 3, 1. So 1 by 1, let's see what happens. At first we have 2, replace here, so minus 16 divided by 3. Here we have 2 cubed is 8, that should be minus 16 over 3 times 8 plus 8 over 2 plus 2 minus 1, we will have minus 16 over 3, right? And then here we have plus 8 plus 1. Let's see what happens. Minus 2 over 3 plus 4 plus 2. That should be 5, 1 over 3 minus 16 over 3 plus 8 plus 1. That should be 3, 2 over 3. So 5, 1/3 minus answer. That should be 1 2/3. So your exact area will be 1 2/3 pi, or we can simplify this. So 1 times 3 is 3 plus 2 is 5. That'll be 5 over 3 pi units cube for the volume of that region. But the main idea here is we have to know the volume about the y-axis have to be pi integral of x squared with respect to dy. That's the main idea behind this part of the question. Now step by step we have to first find x squared, then we replace, solve step by step, and then we replace the limits, and then find the corresponding value for the volume.